Alright class, and the topic is limits of accuracy. Alright, we had discussed number pattern in 4 lectures, all the cases in which we have constant difference and which we have the first difference is not constant. Now limits of accuracy is a short topic, small topic, and inshallah we will cover this topic in one lecture only, that is quite enough. So first thing, what is limits of accuracy? Basically it tells the maximum or the minimum value, right? Maximum or the minimum value. The maximum we say it as upper bound, and the minimum we refer as at lower bound, right? Let's suppose I say that a length of 2 centimeter correct to a nearest centimeter, find upper bound and lower bound. The first thing in the topic of limits of accuracy is that this statement, correct to the nearest centimeter, this statement is very important. If it says correct to the nearest centimeter, that means it talks about 1 centimeter. At first step you need to find out scale factor. And what is scale factor? Basically you need to pick the number that is written with the word nearest. You need to pick that number and divide it by 2. That gives you the scale factor. In that case it's 0.5. Suppose that if it says nearest to 3 centimeter, if example, so scale factor will be 3 over 2, that will be 1.5. that is your scale factor, right? So whatever number written with the word nearest centimeter, you need to divide it by 2, so that gives you the value of the scale factor. Now scale factor is very important when you are finding upper bound. So you will say that quantity, that is 2, plus scale factor, that is your upper bound. You need to add scale factor in our upper bound, so that will be 2 plus 0.5 and it's 2.5, right? Similarly, if you need to find out lower bound, so it's 2 minus 0.5, that will be 1.5. So at upper bound we need to add the scale factor, and for lower bound we need to subtract. Alright, first you need to note it down in your copies. You have a minute to note it down, and then we will start the questions from the worksheet. So make sure that you have the idea of the scale factor. Whatever the number is written with the word correct to the nearest, you need to divide that number by 2. That gives you the value of scale factor, and once you had find the value of scale factor, you just need it to add in the upper bound and to subtract it from the lower bound. How you are going to apply it, we are going to look it into the worksheet question. Alright, now moving on to the worksheet question. Worksheet is available at the homework manager with the title of worksheet, and you can find out with the name of the topic. Now first we are going to start from question number 1. Read the question carefully. It says the measurement of a rectangular lawn correct to a nearest meter. What is hidden in that statement is our scale factor. Alright, is 15 centimeter long and 9 centimeter wide. So roughly if I sketch a rectangle, right, I say that it's 15 meter and it's 9 meter. That is a rectangle. After that, we need to find out the scale factor. And the scale factor is what? The number that is hidden here, it's 1. Correct, to the nearest. If no number is present, that means it's 1 meter. You need to divide 1 by 2, that gives you the value of 0.5, and that is your scale factor. Right? Okay. The least possible value of the perimeter of the lawn. So if you have a length of 15, so we have the upper bound of 15 and we have the lower bound of 15. The upper bound of 15, that will be 15 plus scale factor, it's 15.5. And for lower bound, it's 15 minus 0.5, and that gives you the value of 14.5. Right? For perimeter, we know that it's sum of all sides. So if the perimeter is about the least possible, right, that means now you need to find out the lower bound. And for lower bound, I will consider not 15 but 14.5. So the perimeter of rectangle is 2 times of L plus B. That is the working formula, 2L plus 2B, all lengths. So the 15 lower bound is 14.5, and for 9th, for 9 the upper bound is 9.5 and the lower bound is 8.5, right? So we need to find out the lower bound, so it's 8.5. Calculate it. So 14.5 plus 8.5, it's 23, times 2, it's 46. So the perimeter, lower bound perimeter is 1446 and the unit is meters. So that is the perimeter, lowest perimeter. Alright. For 1B, the greatest possible value of the area. For greatest possible, that means it talks about the upper bound. So area of a rectangle is L into D. L is what? The length 15 has an upper bound of 15.5 and the length 9 has an upper bound of 9.5. So you need to multiply 15.5 times 9.5, it's 147.25, and that is the upper bound of the area. So first note down the solution in your copy. You have 1 minute. Start. All right. Moving on to the next question, it's question number 2. Mariam's height is 1.52 meter, correct to the nearest centimeter. The scale factor is hidden inside the word nearest centimeter. If there is no number, that means it's 1. So first I'd find out that a scale factor is 1 over 2 and it's 0.5. Alright. State the lower bound of her height. Her height is 1.52, right? For the upper bound, you need to add the scale factor. Alright, the second thing here is the unit. Here we have 1.52 meter and here you have a centimeter, right? That means it includes unit conversion. Since the scale factor is in centimeters, so I will convert 1.52 into centimeter. So that will be 1.52 times 100 is equals to 152 centimeter. Alright. Now the length is 152 centimeter. If I need to find out the upper bound, so it will be 152.5, add 0.5, and for lower bound it's 151.5, right? So the lower bound of her height is 151.5. That is the first answer. For the next part, the length of the paces is 0.55 meter. She walks at a constant speed of 2 paces per second. Calculate the distance in kilometers that she walks in 1 hour. Alright. What value we have known? We know that she walks at a speed of 2 paces per second. Alright, and the distance she covers, the length of the pace is 0.55 meters. So first thing, the time is given that the distance in kilometers that she walks in 1 hour. We know that it's 2 paces per second. So I can write that 2 paces in 1 second, right? And that phrase is this one, at a constant speed of 2 paces per second. In 1 second she walks 2 paces, right? She walks in 1 hour. So that means how many seconds she need to walk? In 1 hour we have 36 seconds. So that will be 3600 divided by, it will be x. So x will be 2 times 3600, that is 7200 paces. That means in 1 hour she will walk 7200 paces. Now it says the length of the pace is 0.55 meter. The length of one pace is 0.55, so the length of 7200 paces will be 7200 multiplied by 0.55, right? And 7200 into 0.55, it's 3960 meters, right? Because the unit is meter. We need to give the answer in kilometers. That means you need to divide it by 1000. So the final answer, it will be 3.96 kilometers. That is the final answer. She will walk a distance of 3.96 kilometers if she walks for 1 hour with a speed of 2 paces per second, and the distance of one pace is 0.55 meters. That is the final answer. Alright, moving on to the next part, question 3. The length of a piece of string is 0.026. I think the question is incomplete. Let me check the complete question first. No, it's complete. The length of a piece of string is 0.026 meters. So we have a length of 0.026 meters. Correct to the nearest millimeter. So first you need to convert your unit into millimeter, and for that purpose we need to multiply by 1000. So 0.026 multiplied by 1000 is 26 millimeter. Alright. The scale factor is nearest millimeter. That means the scale factor we have in this question is 1/2 millimeter, or 0.5, you can say that. Write down the lower bound. So for 26, the upper bound will be 26.5, the lower bound will be 25.5, and that is your answer for the lower bound of this length. Alright, moving on to the next question. The distance traveled by an object was 230 meters. Correct to the nearest 10 meters. So before reading the further question, I will find the scale factor, and that will be 10 divided by 2 is equals to 5. What is the procedure to find out the scale factor? Whatever the number written with the statement correct to the nearest, you need to divide it by 2, and that gives you the value of scale factor. The time taken was 7 seconds correct to the nearest seconds. Alright, so it's 1 upon 2. So the distance is 230. The upper bound will be 235. The lower bound will be 225 because the scale factor is 5, right? The time is 7 seconds. And the scale factor for time is 1 upon 2, that means 0.5 seconds. So if you have a length of 7 seconds, upper bound it will be 7.5 and lower bound it will be 6.5. Complete the statement in the answer space. So for first part you have the answer, this one. That are the answers of the first part. So the lower bound of the distance is 235, the highest is 235 and the lowest is 225. For time we have 7.5 and 6.5, so you have got the answer of your second part here. What was the least possible average speed? Now average speed, how you are going to find? We know that distance is equals to speed multiplied by time. If I make speed the subject, so speed is equals to distance upon time. Now we need to find out the lowest possible value of speed. For lowest possible value, time must be highest, right? And distance must be lower. So the lower value of distance is 225 and the highest value of time is 7.5. So 225 by 7.5 gives you the value of 30. So average speed is 30 and the unit is meters per second. That is your answer. Alright. Moving on to the next question. The cost of a chair is X dollar, $70 correct to the nearest 10. Alright, so if the amount is $70 and scale factor is 10 upon 2, that is $5. So the 70 has upper bound of 75 and the lower bound of 65, right? Similarly, the cost of a desk, $Y, that is $900 correct to the nearest 50, that means scale factor is 50 divided by 2, $25. So the length 900, the upper bound is 925 and the lower bound is $875, right? So all the four lengths, all the four upper and lower bounds we had find out. So for $X, the lower bound is 65, the upper bound is 75. For desk, it's 875 and 925. Find the lower bound of the total cost of a desk and 4 chairs. Basically, chair is X. So 4 chairs, that means 4X. We need to find out the total cost of a desk. Desk is Y plus 4X. And we need to find out the lower bound. That means you need to place the value that are lower bound of each category. So the lower bound for Y is 875 plus 4. The lower bound of X is 65. 65 times 4 plus 875, it's 1135, not Y, it's total cost. Total cost is $1135, that is the lower cost. Alright, note it down. I hope that you have the idea of limits of accuracy, how we are finding it, how we are finding the scale factor, the upper bound, the lower bound. Not the difficult topic, it's an easy one. So moving on to the next part, I hope that you had noted down the solution in your copy. The population of a city is given by 2,80,000. So first the original figure is 2,80,000 correct to the nearest 10,000. Now scale factor, how we are going to find the scale factor? The number is 10,000 and you need to divide the number by 2, so it's 85,000. That is your scale factor. The original length or original figure is 2,80,000. For the upper bound and for the lower bound, you need to add and subtract. So 280,000 plus 5,000 is 285,123, right? And 280,000 minus 5,000 is 275,123. Right? We had the upper and lower bound of the figure 280,000. State the greatest possible error in the given value. So the greatest possible error means the upper bound. So the maximum possible value that might be wrong is 2,85,000. That is the maximum possible value. Alright, so that is the answer of the first part. For part B, the dimension of a rectangular card are 7 by 4. So we have a rectangle 7 by 4. Correct to the nearest centimeter. That means the scale factor here is 1/2 and that is 0.5. Calculate the smallest perimeter. So first 7, upper bound 7.5, lower bound 6.5. The length is 4, upper bound 4.5, lower bound 3.5. Why we are adding and subtracting 0.5? Because the scale factor is 0.5. You need to find out the perimeter of the lower perimeter. So perimeter working formula is 2 times of L plus B. Since we are finding out the lower bound, so I am going to place lower values, that is 6.5 and 3.5. So 6.5 plus 3.5, it's 10. 10 times 2 is 20. That is the perimeter of the lower bound. Alright, note it down. Not a difficult topic, easy topic it is. I hope now you had got the idea. Done? Note down it in your copies and then I will start the next question. Alright. Now moving on to the next question. In a race, an athlete runs 1600 meter at a speed of 6 meters per second. It's 6 meters per second. The distance is given correct to the nearest 100 meter and speed correct to the nearest meter per second. Complete the two statement in the answer space. So first you need to give it a try by yourself and then I will start. So you have a time of 2 minutes to start. Done? All right. So first, we need to find out the scale factor. So it says the distance is given correct to the nearest 100 meter. That means the scale factor for distance is 100 divided by 2 and it's 50. And speed correct to the nearest meter. For speed, the scale factor is 1 upon 2, that is 0.5, right? So what is the value of distance? Distance is 1600, the upper bound will be 1650 and the lower bound will be 1550. For speed, the speed is 6 meters per second, the upper bound is 6.5 and the lower bound is 5.5, right? We need to find out the values of the upper and lower bound of distance and the speed. So moving on to the next question, or it is the last question of the worksheet. It's question number 8. The mass of a marble is given as 5.4 grams correct to the nearest 10th gram. Now there is a confusion word, that is 10th of a gram. The mass of a box is 85 correct to the nearest 5. So first you need to give it a try by yourself, and the time you have is 2 minutes. So give it a try and then I will start. So start. Done? Alright class. So first thing, the mass of a marble is 5.4 grams, but it says correct to the nearest tenth. Now tenth is what? Tenth means 1 upon 10 and that means 0.1. The working for scale factor is whatever the number is written with the nearest, you need to divide it by 2. So for that case, scale factor is 0.1 divided by 2, that means 0.05. That is the scale factor. Alright, so that mass is 5.4 grams. The upper mass, it will be 5.45, right? You need to add 0.05. The lower bound will be 5.35. You need to subtract 0.05 from 5.4. So that 10th is a confusion here. Mostly students take is at 10, but it's not 10, it's 10th. The mass of a box is given 85 grams correct to the nearest 5. So it's 85 nearest 5 grams, that means scale factor is 5 over 2, it's 2.5. So the upper bound is 87.5 and the lower bound is 82.5. You have all the necessary information to complete the question now. This part has been done. Mass of one marble. So mass of a marble is lower bond is 5.35, upper bond is 5.45. It's 82.5 and it's 87.5. Find the lower bond for the total mass of box and 20 identical. Box and 20 identical marbles. So the lower bond for the box is 82.5 plus 20. The lower bond for the mass is 5.35. So you need to calculate it. 5.35 multiplied by 20, it's 107 plus 82.5, it's 189.5. That is the total mass, but it's lower bond, right? And it's 189.5, so that is your final answer. Alright class, so that is the end of the topic limits of accuracy. We had done the whole worksheet in which we had 8 questions. The concept, the working is totally same for all the questions. First you need to find out the scale factor and then you need to find out the upper bound or the lower bound. For upper bound you need to add the scale factor, for lower bound you need to subtract the scale factor from your given length. Alright. So that is enough for today class. Inshallah next class we are going to start new topic. Till then take care and Allah.